Good day, students. So, today we'll be looking over equations again, but the difference with this type of equations is that the variable is at the denominator. It's not at the numerator, it's at the denominator, which can make it a pretty complicated, if I could say, but like nothing is impossible, right? So, let's get down to business, okay? So, first off, we have 3 over x plus 2 equals 5, right? Now, what I like to do when we have a denominator that has a variable, let me show you. What I like to do is multiply it out, right? Because how can I get rid of this x in the denominator? I have to multiply it with x on top, right? And then this x will cancel out with this x, okay? So how can I do that? All right. You multiply every term with the denominator that you're trying to cancel. All right. So you're trying to cancel x, which means you're going to multiply every term by x. And then this x will go away eventually. Okay. So we're going to have 3 over x multiplied with x plus 2, which is multiplied by x, and 5, which is multiplied by x. Okay. You multiply out x on every term, and then this denominator will cancel with that x, and then you don't have a variable in a denominator anymore, and then you just have simple terms that you can deal with. Okay, so now this 3 is multiplying with x, so we can just cancel these x's, and then we're going to be left with 3 plus 2 times x, that's just 2x, which is equal to 5x. And now we're going to try and move the variables to one side and the constants to one side. Okay, so let's move this 5 to this side. Okay, and we're going to have 2x plus 3, right? So how do we get rid of this 5? We minus another 5x, right? So we'll write this 5x on this side as well, and we're left with 0 over here, and then it's just 2x minus 5x plus 3. Now how do we get rid of this 3? We minus, right? So we say 2x minus 5x plus 3 minus 3, because we're trying to get rid of this positive 3. And what we do on one side, we do on the other side as well. Then we're just left with 2x minus 5x, that is negative 3x. Now, what can we see here? We see that, okay, we have a negative 3 multiplying with an x. How do we get rid of that negative 3? We do the opposite of it, it's multiplying. Therefore, we'll say negative 3 divided by negative 3, okay? And what you do on one side, you also do on the other. And negative 3 divided by negative 3, that's just 1. 1 here as well. Those negative cancel. 3 by 3 is 1. So our x is 1. Now, if we substitute 1 over here, 3 divided by 1 is just 3. So 3 plus 2 does indeed equal to 5. Okay, let's do the second one. Now we have 4 over x minus 2 over x plus 1 is equal to 2. Same thing. What are we going to try and do? We're going to try and cancel out these denominators that have variables. And how can we do that? We multiply every term with that kind of denominator. That variable we multiply it out on every term. In this case, look at the variable that we have. It's x, right? So how can we get rid of x? That's dividing. We need an x that's going to be multiplying with that term. So what we're going to do, we're going to say multiply with x, all right? And this means that you're going to multiply x with every term, okay? Minus 2 multiplied with x over x plus 1 multiplied with x equals 2 multiplied with x. Everything, all right? Everything. Now, this x and this x, they'll cancel out. This one and this one will cancel out. So you're left with 4 minus 2 plus 1x equals 2x, okay? Then you're left with 2 plus x equals 2x. Now, like I said, we normally prefer the variables to be on the left and the constants on the right, but like it's not a requirement per se. Whereas like it should all the variable should always be on the left and the constant should always be on the right. You know, these variables can also be on the right. You know, it just depends what's convenient at the time. Now, it's not going to be wise for us to take this 2x on the side like we did in the previous example. You saw how long that took. So let's just take this x to the side because we're left with one constant anyways. So we're just going to say 2, right? 2 plus x. Now we're going to try and cancel out this x. So we're going to say minus x, right? And what we do on one side, we do on the other. The minus x plus x, that's just 0. Then we're left with 2. 2x minus x, that is just x. So we can write it like this then. We just swapped it, right? Just swapped it. Just swapped it, okay? And then we got our final answer, x is equal to 2. We could have left it like this. There was no need to change it. But, we just like to leave it this way, the variables are left, But in terms of calculation, it doesn't always have to be on the left. It just depends on what's convenient at the time, whether I should put it on the left or I should put it on the right. Okay, now let's check our answer. We got x is 2. It's 2 over here, 2 over there. Now 4 divided by 2, that's 2. Minus 2 divided by 2, that's 1. So 2 minus 1 is 1. So 1 plus 1 equals 2. So our answer is indeed correct. Now let's do the final one. 2 plus 5 over x plus 2 equals 4. Now, what do we see that's different? Now, the variable, like the denominator, doesn't only consist of just a variable. There's also a constant. So, like, it's just this one big thing that's underneath, right? But like I said, the only way to cancel this is to make sure you multiply every term with what's at that denominator that you're trying to cancel. So same steps apply. We're going to try and multiply with x plus 2. Every term, we are going to multiply it with x plus 2. So let's do that. So 2 is going to be multiplied with x plus 2, plus 5 is also going to be multiplied with x plus 2, x plus 2. Also 4 will also be multiplied with x plus 2. All right. Now, let's do this. Let's distribute this 2. So it's going to be 2 times x and 2 times 2. 2 times x, that's 2x plus 4 plus, now this x plus 2, which is in brackets, will cancel this x plus 2 that's at the denominator. Then we're just left with 5. Then this is equal to 4 times x plus 8. Okay, and this simplifies to 2x plus 9, 4x plus 8. Now I'm going to teach you how to skip steps, because you don't want to write minus, 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 plus like all the time, right? Sometimes in the exam, there's no time, right? There's just no time. And then there are kind of things that you can skip, which is allowed, because it means you know what you're doing. So we know that this 4 is going to go this side. This 4 is positive. How are we going to get rid of it? We need to minus 4. So let's just say 2x minus 4x on this side, right? And then we're left with 8. We just remove this 4. If it was positive 4 on this side, then we just write a negative 4 on this side. We just moved it onto this side. Okay? Same thing with the 9. This 9 is positive on this side. Let's move it to the other side, and then it's going to give us what? 8 minus 9. Okay? Now 2x minus 4x, that's just negative 2x. Then we're done with that. Okay? Now 8 minus 9, that is negative 1, negative 2x. The same thing can be done with multiplication and division. We know that this negative 2 is multiplying the side. Why don't we just say, the only way to get rid of that multiplying 2 is by dividing it with negative 2. So while it's multiplying here, let's make it do the opposite on the other side. All right. It was multiplying, we moved it to this side, and now it's dividing. Whenever you cross that equal sign, you're going to do, the function is going to do the opposite of its original. All right. Here originally it was negative 2 multiplying. When we moved it over the equal sign, we made it divide. It's going to do the opposite. And negative and negative will cancel, then we just left with a half. Now our x is a half, all right? Our x is a half. Now, if we're going to substitute that half over here, it's going to be a half plus 2, right? 5 divided by 2.5 is what? It's 2. So 2 plus 2 equals 4. And that means all of our answers are correct. Right? There's no set way of doing equations. You can skip steps when you know what you're doing. But just make sure that the examiner will also understand where you're at. Okay? And yeah, cheers.